Welcome to Facts Daily. Ever wondered why we don't just fly off when the Earth spins? Or why we feel a pull when the car suddenly accelerates? Welcome to the of motion. Motion, in its most basic form, is the phenomenon that allows us to move and interact with the world around us. It's the reason why we can walk, run, or even simply pick up a cup of coffee. But have you ever stopped to think about the forces that make all of this possible? Enter Sir Isaac Newton, a man whose curiosity led to the discovery of the laws that govern how things move. These laws, known as Newton's three laws of motion, are the foundation of classical mechanics. They explain why we don't fly off the Earth, why we're jolted forward when a car suddenly stops, and so much more. Now let's dive into the first law that Newton introduced us to. Imagine sitting in a car when suddenly the driver hits the brakes, you jerk forward. But why? This is all about Newton's first law, also known as the law of inertia. Picture this, you're cruising down the highway, you're not pushing the gas pedal, but you're not hitting the brakes either. And yet, the car keeps moving. That's inertia in action. An object in motion will stay in motion unless an external force acts upon it. Now let's go back to our scenario. You're in the car, the driver hits the brakes, and you lurch forward. That's your body wanting to keep moving even as the car stops. It takes the seatbelt, an external force, to halt your forward motion. The same principle applies to objects at rest. An object will stay put until an outside force nudges it into motion. So remember, an object will not change its motion unless a force acts on it. Now, onto the second law. Ever tried to push a heavy object? It's a lot harder than pushing a light one, right? That's Newton's second law in action. This law, also known as the law of acceleration, tells us that the force applied to an object is equal to the mass of the object multiplied by its acceleration. Let's break that down. Imagine you're pushing a feather and then a boulder. The feather, with its minuscule mass, moves easily, while the boulder, heavy and imposing, requires a much stronger push. That's because the boulder's greater mass requires a larger force to change its speed or direction. In other words, to accelerate it. This principle is crucial to understanding how everything moves, from cars on a highway to planets in space. It's the reason why heavier objects feel harder to push or pull. So more mass equals more force needed to move it. Now let's look at the final law. Scene script. Ever jumped off a small boat? What happens? The boat moves backward. That's Newton's third law for you. This law, often referred to as the law of action and reaction, is all about balance. When you jump off the boat, you're applying a force to push yourself forward. But in the process, you're also pushing the boat backward. The force you apply to jump off the boat, the action, results in an equal force pushing the boat in the opposite direction, the reaction. Imagine trying to push a wall. You exert force on the wall, but the wall doesn't move. Instead, you feel the force pushing back against your hand. That's the wall's reaction to your action. This law is not just about boats and walls, it's everywhere. From the recoil of a gun to the propulsion of a rocket, Newton's third law is at play. So, for every action, there is always an equal and opposite reaction. That's all three laws covered. So, we've traveled through the world of motion and discovered Newton's three laws. Let's take a quick trip down memory lane. We started with the law of inertia, which tells us that an object will remain at rest or in uniform motion unless acted upon by an external force. It's why your coffee doesn't spill when you walk at a steady pace. Then, we moved on to the law of acceleration. This law explains that force is equal to mass times acceleration. It's the reason why it takes more effort to push a heavy object than a light one. Finally, we encountered the action-reaction law. For every action, there's an equal and opposite reaction. It's the principle that makes rocket propulsion possible. These laws aren't just theories, they are the foundations of classical mechanics that govern our everyday experiences. Remember, the world around us moves according to these laws. So next time you're in a car or pushing a shopping cart, think about Newton's laws of motion. Thanks for watching.